go ahead and get started. I will be sharing this screen, so hopefully you guys can see everything. We tested it out. We tested out the workflow and everything seemed to be functional. If there's an issue, please put it in the chat. I'll be monitoring the chat just in case, something pops up. Or obviously, if you have questions or want to throw rocks or discussions, tell me I'm crazy. You can do that as well. All right, so let's talk about Linux as it relates to cloud and cloud security. Now, one of the things that we're going to be kind of diving into is the data and the research that we at Trend Micro have kind of found, and just a little bit about us, I guess, if I want to back up before I deep dive in. Trend Micro, 33-year-old software company. We've been around for 33 years with 57 different products, 7 of which are cloud specific. And I'm Aaron Ansari. I run the cloud security program globally at Trend. So we have tens of thousands of customers that are using these 7 products. And one of the things that we do is that we take aggregate data, obfuscated aggregate data, it's not specific to customers, and we do research on it, right? And so since we've had several products for several years that are related to cloud and cloud security, we take that data and we mine it to get relevant and pertinent information that's patterns or things that we're seeing that we then pass on to our customers or you via conferences like this. And so that's what we're going to do today. We're going to take the data that we've mined specifically as it relates to Linux and cloud security. And we're going to dive through it. Now, it's not going to be, a super deep dive into everything, but it will go through and tell you, kind of what we're seeing, the patterns and forgive the pun here, trends of what's popping up in what we're seeing, and some recommendations on things that you should pay attention to and take with you as you're going through and building out your cloud portfolio, doing a migration to the cloud, or just tweak and refine kind of the stuff that you're doing. So let's talk a little bit about Linux as it relates to the cloud. And some of this data, I should put a little asterisk on this. Some of this data, we have customers that run hybrid environments, so that run a private or something that's not necessarily in the public cloud, but run cloud related services or softwares that have a private cloud presence, but that was a small percentage of the thousands of customers that we looked at. So most of the data that you're going to see is related to strictly public cloud consumption. So something like an AWS, Azure, GCP, VMware, Oracle Cloud, one of those things, right? So when you look at the hosted environments or the environments that are being built in public cloud workspaces, this one actually surprised me, was the ubiquity of kind of Linux that's out there. And Linux is a big umbrella, right? There's all sorts of different variants of Linux, and we'll talk about that. But it surprised me that the market was so heavily, 61% dominated by Linux instances. And so that, first and foremost, was something that we've been doing this report for a year. So when I talk about being surprised, this was something that happened back at the beginning of 2020 here, sort of thing. So, that and getting that data and kind of diving into it and parsing and piecing it out was something that was very, very kind of a personal passion of mine, to get in and learn and talk to our customers and hear what was happening. But, if you look at your environment in the public cloud, you should see something akin to this, right? A larger majority being Linux-based from an operating system standpoint, and from the workloads and the environment itself that's either in the containers or running with the services in the cloud, versus what's happening at Windows. And there's a couple of reasons for this, which we're not going to get into now because we're talking about security. But at a high level can be everything from complexity, configuration, security, and cost, right? There's a cost that's associated with Windows that's not necessarily incurred with a Linux environment. And so I said not necessarily, sometimes it is, but those things tend to, kind of drive those factors as it relates to how our customers are building out their environment. So when I say Linux, what do I mean? Well, as we've talked about, there are many different flavors of Linux. Just like there are many different flavors of Windows, right? You can run Windows servers 2008, 2012, 2020. You can run SQL Server. You can run different variants of things, right? But there's different variations of Linux as well. And so predominantly what we had was Red Hat Linux, which ironically I was actually just in Raleigh, North Carolina, which is where the Red Hat Linux headquarters is from their purchase from IBM. And so I was talking to some people there as part of this, and they're actually seeing something very similar, right? A third of the instances in public cloud workspaces are running off of Red Hat Linux. And then there's all sorts of other variants. Pretty much when you get to CentOS, everything takes kind of a sharp nosedive, and you'll see that pattern as well among our data. And note that our data wasn't unique to just one type of customers like healthcare or finance. This is a broad spectrum of over 1,060 some odd different customers that we worked with that covered the gamut, right? From a small startup that had $50 million in investments to a large multinational corporation with hundreds of thousands of associates that's been in business for 100+ years. So this isn't, just kind of looking at one finite space. We're really doing some broad analysis here. So, you kind of see that if you go back, it makes sense. Let me go back. It makes sense that this, sort of variation, there's a lot of different pieces and parts of Linux that can be put into the public cloud that's there. And, here's what we looked at, right? And so when you look at that, let's take a look at, kind of the attack vector, the attack surface that sits and lives there. And we're going to look at this in two different ways. We're going to look at this from an OWASP top 10 sort of attack vector space. And I know we're not talking just application security here, but it's a good framework to kind of look at it. And then we're going to look at sort of the CIS benchmarks and outside of the OWASP top 10 sort of thing. So we'll kind of examine, what's happening from both perspectives. And if you look at that threat landscape, you see that there's quite a bit of, I guess I'll call it malware. If I was to use a generic, kind of large term there that could be under coin miners or web shells. There's quite a bit of what I'll say malware, right? We had 13 million events that we were looking at over these 1,060 some odd customers, and almost a third of them, 25% of them were related to kind of coin mining. And this makes sense, right? Organized crime and or nation states that are actors are looking to make money. Very famously in 2015, North Korea almost got away with $1 billion transferred, ended up getting away with $80 million transferred into their bank account via a series of very, very complex breaches and social engineering exercises, right? And so nation states as well as criminal actors are looking to get money. And if they can use your compute or your public cloud instances to make them money, literally, you're paying for the cloud instance that they're making money on with a coin miner. Why wouldn't they? It's kind of a no-brainer. And so how this happens and what led to this is kind of some of the stuff that we dived into the report. But it was interesting to kind of see that malware, I guess, was a quarter of what was happening. And these were various backdoor web shells that were kind of a part of this, doppelpayminer, double extortion, all sorts of stuff that was a piece and part of this. But if you go outside of or if you look at the specific vulnerabilities that were exploited to leverage this, right, you see kind of a large bit of volume of the hundreds or some odd thousand Linux hosts that we looked at, the top 20, kind of flavors of Linux, and you will see a little bit of Unix in here that were part of the triggers for vulnerabilities, right? And there were various Apache, struts, WordPress, file managers, vBuilt, SaltStack. Those sorts of exploits were used to take advantage of some of the vulnerabilities in this specifically in order to install the coin miners, web shells, and various malware. I guess I'll say that was a part of that. So that kind of sets the tone of, hey, Linux is used in the cloud. Hey, there are a lot of variants that are used as part of it. And, oh, by the way, that then leads to various vulnerabilities and threats that can be exploited. Now, let's look at the specifics of those threats. And we have a list of all the CVEs and all that sort of stuff that was exposed as part of our research that we've published. You can easily look up this report and get more data and information from it from there if you're interested in the specific CVEs. What really surprised me about that, by the way, was some of these CVEs that we were looking at were 2017, 2016, like, virtual patching and patching of environments or configuring your environments in a much more secure way. Just a simple best practice that just wasn't being done in certain instances. So let's look at the attacks, right? The specific exploits that were used. And, 20 some odd percent were OWASP specific ones, but meaning kind of common known application-based attacks. And then 75% or more was non-OWASP based attacks. And that's actually kind of something that's really important. So if you look at the OWASP top 10, which by the way was recently updated, if you haven't seen, OWASP top 10 hasn't been updated since 2017. They're publishing a draft version of the 2021 version right now. So if you haven't looked at it, go take a look. It's kind of a reshuffling of a lot of things because we're not learning, bluntly. But go take a look at that if you haven't taken a look at that. So, brute force attacks, SQL injection, all the common things that we've been talking about for the better part of a decade are some of the things that we looked at. So with Linux being the first choice for web server applications, right, OWASP top 10 becomes more relevant when you're looking at the operating system, right? And of the things that we were looking at from a security standpoint, it's almost like the common features of the OWASP top 10 aligned to the common threats and vulnerabilities that we were seeing being exposed, right? SQL injection, command injection, cross-site scripting, insecure deserialization. All these things are top of the top 10 in that particular order. And hey, sure enough, all these things were being exploited by the tops of those things. But let's take a look outside of just what was happening in the OWASP top 10 to kind of talk about some of the volume of activity that could be compared outside of that, right? And so if you look at what else was coming, we were seeing kind of the traditional, I guess I'll say, easy attacks, for lack of a better term, that were a part of what was kind of being hit from a cloud environment. And this was alarming. Right, to not set up your Linux instances to deal with brute force attacks or to deal with something as simple as directory traversal, right? Like rooting out your whole directory and spidering the entire thing. That was alarming because these events are logged. These events are available as part of the operating system as well as your cloud provider. You just have to look. Or you just have to, kind of turn them off, right? If brute force is something that you're susceptible to, change your application or change your operating system settings to not allow, logins to go after 3 attempted failed logins or 5 attempted failed logins, whatever your policy is for your organization. So we've set the foundation, right? We know that Linux is prevalent in the cloud with the various pieces of it. We've talked about the vulnerabilities and threat attack surface. We've talked about kind of what we saw from a top 10 of that sort of thing. So let's look at the exploits and why or how these were part of the exploits. And so we look at the open source security and or the software supply chain attacks. And one of the things that we do well is we take a look at the code pipeline, like how an application is built. And we align that to just kind of how manufacturing is built, right? When you're building something, you have various suppliers that ship you things from all over the world. You kind of assemble it, put it together. You put it on a truck or a train or an airplane. You ship it off to some sort of receiver, a middleware, a store, somebody that sells your wares and goods, and then that goes to the end customer. Well, the same sort of thing can happen in a software instance, right? And there are actually regulations that are either being talked about or have been passed to identify software suppliers in your software supply chain, right? So this isn't necessarily a foreign concept or anything groundbreaking or earth-shattering. This is something that you should probably pay attention to because you might be federally required at some point to understand who the suppliers to your code are as well. And this gets into a whole open source discussion and some stuff that is outside the purview of this discussion, but is something that you'll have to pay attention to. But think about your software package, your application that you're building in the cloud on Linux, with Linux-powered services in the same manner that you would think about construction of software. You've got, source dependencies, you've got open source code, you've got code that you're reusing from other systems, you've got code that a vendor, you've hired Accenture, Deloitte, KPMG, name whoever consultants, Slalom, to come in and do some cloud coding for you. And they're, building and sourcing these things. They're your suppliers, right? And you construct it in your four walls or your four virtual walls. You then push it out via your network. It's probably, cloud software as a service based, right? It lives and it's deployed out into your systems, and your consumers sort of use it, right? And that's the way that, kind of software is designed. And, if you look at the supply chain and, the attacks that are hitting it from a supply chain standpoint, those same sort of things can be applied to the software supply chain, right? And so there's concern about security vulnerabilities that are used in the software supply chain as well, which make it something that you should kind of be paying attention to. Apologies, I should have zoomed in on this slide so that you could see it a little better. But like I said, you've got tools, you've got processes defined that build this. You want to do the same sort of functionality there. And just like in your supply chain, right, when you're able to take something constructed, drop it in and build off of that framework, you're able to do the same thing from a container perspective as well, right? So we wouldn't be able to talk cloud today if we weren't talking something about, Kubernetes and Dockers and API abuse that's tied to the container environments that some of these instances are housed in. We'll talk about software-defined infrastructure, secure containers, infrastructure as code, and those sort of things from a mitigation standpoint later on. But let's talk a little bit. I'd be remiss if I didn't have a discussion about cloud security and not mention container security, right? And so there is the possibility for leaking containers, hijacked image registries, all sorts of things, depending on the type of container and the version of container that you're using in your environment. Fact, right? Something that's just simply there. Regardless, though, with what we saw outside of kind of the common sort of attacks was embedded images within the malware, which again shouldn't have shocked me, but it was like, really? Why are we seeing you use a container that has malware, that's already a part of it straight from the get-go, right? Something that's poisoned straight from the source, right? Hijacked registries or just, API specific abuse. And we took a look at the specific components or the types of images that were built as part of this, right? And so I zoom out just really, really quickly, just looking at the various Docker images and the API abuses that were there. Our list again had, our table had a bunch of data. I kind of took the top 5 that were here, right? And we broke it down into the, I sort of focused on the left side of this chart, critical and high vulnerabilities that were there as part of these various containers. And it was a little bit kind of that bell distribution, right? There's a lot of medium, some lows, but more high and critical than I kind of wanted to see. The bell was skewed a little bit based on the type of container that we're using. So again, the Linux environment that you're using, you got to ensure that the functionality, the core image and the core functionality that you're using as part of that is taken care of and kind of bolt tight with that. So we've done the foundation. We talked about the vulnerabilities. We took a look at the specific ways that you build your environments via the software supply cycle and the container images that are used to do that. What can you do now that you've identified the problem, right? How do you secure your servers? It's pretty clear that organizations are going to depend on Linux, and you have to have some sort of Linux expertise, right, for your digital infrastructure. And this could be everything from your mainframe servers, web deployment sort of stuff that you have on-prem to what we're talking about here is cloud-specific instances, public cloud-specific instances of your Linux environment. And there's a lot of things that'll attack, right? There's a lot of threat vectors and attacks that could hit this based on the various pieces of your supply chain, everything from the code itself to the application front door, to the network supporting it, to the services that it's built off of, to the misconfigurations that you did when you deployed it. Maybe you deployed everything correctly, but you didn't encrypt your storage, and your storage container is open to the world. That's not a good thing, and that's not necessarily a hack per se, but it is something that was exploited as a vulnerability. And so, what do you need to do to be able to fix it? Well, it'd be easy for me to just come here and say, hey, you should just buy this software and kind of use this software to fix it. And that's something that I'm sure every vendor that you've ever spoken to says. That's not what I'm going to do, though. Rather, what I want to do is talk about the things that you should just do out of the box, right? I mean, I was alarmed that you take a Kubernetes image that's exposed and instantly has, Mimikatz running on it. Like, what? How does that even make sense? Why wouldn't you start with something that you knew was secure in the base image, right? So use what you've got, right? And if you're using Linux, there are some very simple things that you can do, such as, IP tables, right? That's the Linux rule-based firewall that is there, easy to set up. It's a utility that it can spec the tables, IP packet filters, and the rules, that are all surrounding your Linux kernel. And it's there, it's available for you, and it's something that's free and part of your image. Do it, right? Secure computing, right? This is a kernel that kind of restricts syscalls. So this is something that you can filter the syscalls, right? Almost like identity and access control for your syscalls of which system is executing what piece on your system, right? So only allowing the right syscalls to happen is something that is kind of fundamental and something that you should take the time to do when you're setting up your environment. Application Armor, it's a Mac, a mandatory access control piece that's available for Linux. It's kind of profile based, but it's something that you can individually containerize programs to only run within the way that they're run. And you can see now, if you layer these on top of each other, you're going to start to build a secure Linux environment and a secure Linux environment in your public cloud, which is huge, right? SE Linux is security enhanced Linux. This is a application hardening that's kind of based off of mandatory access control that you can use to turn on, kind of by a policy base to protect and secure things, right? GER security, PACS, these sorts of things, look them up for IPS and intrusion prevention and role-based access control. But again, these are things that are provided to you via the OS and via the kernel. You should turn them on. You should have them as a piece of functionality, and you should utilize them as part of your base image for how you're stamping out your cloud environment. So every time you set up a Linux instance in your public cloud, you have these things turned on. You have logging and monitoring turned on, and you've got people and processes to monitor these things to ensure that the right thing's happening. Now I'm preaching from an ivory high tower here, right? We eat our own dog food, right? We have public cloud instance. I mean, we spend millions of dollars a month in our public cloud environment. And we have, public facing Linux environment that's set up, private versions of it. And I went in and I said, okay, let's take a look, guys. If we're seeing these best practice recommendations and we're sending these out to our customers, what are we doing internally to set up our environments? And I was pleasantly surprised, right? Not all of this, but a majority of what you just see out of the box with the various instances of Linux that we had, we set up and configured correctly. So knock on wood, that was something that was good and something that was positive for our team, kind of internal to the security team here. But as I mentioned, you don't have to go this alone. You can have partners. You can have people that you trust to work with you to help you configure this correctly. You might not have the expertise in Linux. Some of the customers that I spoke with didn't have the sort of same level of admins or site reliability engineers that were trained or versed in the various flavors of Linux that they had in their environment. And that's okay as long as you identify that gap and fill it, right? And so you have software technologies, you have service providers, you have all sorts of other things to help you fill that gap if you so choose to. And, the easiest thing to do is kind of software, right? You can install anti-malware, you can install, various things that would prevent known scripts from running, that would look at your system, that would look at your environment and look on Linux-based malware that could find, kind of what's happening, right? And what's being done. Configuration assessments, right? You can go through and do a configuration assessment, see if your environment is set up correctly. This is commonly called cloud security posture management nowadays. And there's, Trend Microcloud One has a solution for this, as I'm sure, your cloud provider or cloud partner does. Your public cloud also has services that'll do some of this for you, native embedded within the dashboard of your account management. And so you can go through and ensure that it's properly configured, right? You can ensure that the storage buckets or blobs are configured correctly. You can ensure that identity and access management is done correctly. You can do key management and access rotation of those keys in a secure vault or in a secure methodology. You can do identity and access role-based access control of the people that are in the accounts that are looking and building at your environment. You can do serverless-based security. You can automate this sort of stuff. You can have visibility into the way that your environment is. All sorts of things that can be set up as long as you've got the people and the resources to manage it correctly, right? Some of this comes down to just the simple things. You can have all the security tools and all this sort of thing running, but if you don't have anybody monitoring or working it, not going to necessarily be a successful sort of thing. So configure your environment correctly, right? And do that well. Monitor your activity. And this is just a basic one, but we've set up outside of kind of the software that we have, we've set up chat ops or secure chat ops with some of our customers to where we send critical notifications in Slack to a help SOC team, right? And so high critical, notifications automatically get sent via chat operations to the SOC team, and they can investigate that. And in certain instances, we can trigger events via, like, they say, an AWS SNS trigger off of that chat ops event to kick off a serverless function to run and go through a script and fix or remediate whatever is being done. So kind of some really neat things can be set up if you have the logging in place, have the monitoring in place, have the resources in place to kind of build and do this. And this is basic, simple stuff that I'm not necessarily, blowing your mind here with truth bombs that are just shaking your world. These are the things that you can do. And there's more, right? There's vulnerability assessments, there's intrusion preventions, there's execution control. There's all sorts of other things that you can look at that can be a part of this. As well as you can go through and look at kind of your container security, right? Look at the base images that you've got. Use the security tools that are available to you to detect vulnerabilities beyond just operating system packages, right? So, kind of look at that piece. Look at the actual image that's being used. Like, I couldn't believe that we were finding images with malware installed on it and then stamped out across the environment. And I understand how it happens. I totally understand how it happened. Somebody got into the system and poison the watering hole, and then nobody noticed that and it was stamped out. But for goodness sakes, if you're doing something in a production environment, ensure that the images that you're using are on an updated framework, or Notary users, if you're using Notary, can sign their images to maintain a system of trust, right? That's there for the content and the creator. So do that, right? Is something that's there. And then base identity and access control, right? Are the proper privileges being run within the container? And if it is, right, it's a bad idea to run privileged containers in Docker. Are you doing that? Maybe you are, right? Should you be doing that? Maybe you shouldn't, right? Something that you should take a look on and sort of pay attention to as part of the cloud thing that you're building. So we're working our way down or up, I guess, from the bottom of the iceberg all the way up to the top, right? And we get to the conclusion, right? One of the things that I like to say when I'm talking to customers is identify the problem, fix it, repeat as necessary. Identify the problem, fix it, repeat as necessary. Identify the problems, work on fixing them, and repeat, because it's never ending and you're not going to ever get to the end of identifying the problems. And you might have a long list of problems that you've identified, but work on fixing it and then get to the next problem, right? Obviously, prioritize those problems and obviously, kind of build them out, but you have to learn. You have to learn about what is going to affect you. You have to have the expertise. You might have to have somebody come in and teach you and tell you about what's happening in your environments. It's not a, pride thing. It's not something that you're like, I know what's happening in my environments. You don't. Believe me, I was sitting with customers and finding things that MSPs didn't find, finding things that, they hired a premier firm to come in and do a pen test that didn't find, just ridiculous things that we're finding in production environments. So learn, right? Learn and look and don't take it as a pride thing as to what's happening in your environment. Treat those threats seriously. Take action. Boards, high-level management, everybody's got security on their minds nowadays, and that's just going to continue. So, kind of treat that with severity and react appropriately, and then get that expertise, right? Train yourself, hire more people. We both know that's a hard thing to do, is just say, I need 10 more people. Probably not going to happen. Maybe you can have some project dollars and monies set to do an assessment and have somebody come in and prove that you need 10 more people. But, expertise, level up, get your resources, the training and the functionality that they need to be able to do the work that they need to do, and you will be in a much better position. So let me do this. Let me give you a list to the vulnerabilities that we had. And I'll go through and respond to the chat discussions that were kind of posted here. I know it's been a couple of minutes, but I'll do that. The data from my reports is kind of in that link that I've sent there. No paywall, no registration wall. You can just download and look at that report instantly. So the first question that we had, are we not learning, or we're just changing our behavior? How much of this education problem versus finding the time and resources? I don't believe this is solely a people problem. People and technology is needed. The way that I could define this as a people problem is when it just comes down to ego and pride, people not wanting to even know what is happening in your, not a technology issue, not a software issue, just pride, just being like, I don't think there's an issue. We haven't had an issue. Everything's running and humming in production fine. We're good. And you could call that confidence, but I call it pride and ego. I really think that's something that, we would sit down with these people, and these are customers, right? They're not paying us extra money for us to do this work with them. We would sit down with them and, kind of peel back the onion, and they'd be like, holy crap. We'd find malware running in production environments at our customer sites. And, we'd turn on our scanning technologies and boom, be like, why didn't you have this turned on? Well, it slows down this, or it doesn't, got to build or re-architect your application. So, I don't think it's just a technology or a process thing, but you'd be surprised at what your public cloud would be able to help you and provide you with free of charge, or part of what you're already paying. We partnered with, in certain instances, we partnered with AWS quite a bit to do non-service-based work, meaning, already, hey, just turn on this function, just some tweaks and some configuration fine-tuning that really helped our customers with what they were already paying for, or get the most out of what they were using. So Hans, these vulns that you listed are based on installed software in the operating system with containers, not especially the YAML or Docker file. Details of configurations. At what point do we call the basic server apps vulns? For the most part, yes. They were the software in the operating system within the container, right? And I would follow your argument there of calling these server application vulnerabilities, not necessarily a Docker issue, right? I can bucket it into the Docker issue because you're using Docker to carry that environment out there. But I guess I'm not properly naming it correctly, right? It would be the server or application vulnerability that's living on the container. So I'll update my language to be a little bit more specific in that for sure. So I agree with what you're saying there, and I'll modify my language. Any other questions or comments? If not, take a look at that report and you'll get the data, all my data, and even more data than what I've shared here. And wishing you well. Hope you guys are enjoying this conference. I know I am. and certainly appreciate you being here, and we'll talk to you later. Thanks, everyone.